Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is special palindrome substrings, and it is a medium level problem. So after reading the problem, you will realize that the implementation part is the only thing that makes it a medium level problem. Otherwise, the intuition or the thought process is very straightforward. So we have been given two strings S1 and S2, and we have to make the string S1 a palindrome such that it also contains S2 as a substring, right? And in each operation, we can like make any character, take any character of S1 and like change it according to our wish. So we can change any character of our string S1, right? And we have to do this in minimum number of operations, obviously. So in this particular problem, I'll explain you with these sample test cases. So these are the test cases that we have with us. So for example, in the first test case, the input string is A, B, A, A, and the second string is BB, right? So essentially what you can do is you can take this particular character and change it into B. So A, B, B, A, it will be like this, and this particular string is a palindrome which has a substring BB in it, right? So this to make this particular string from the string S1, I just had to change one single character. So the answer for this particular test case would be 1, right? And coming on to the next test case, which is A, B, B, T. Now this is the string S1 given to us, and the string S2 is MR. Now you can see that there is no place you can fit this particular thing because M and R, like neither of those is a character present in the given string S1. So one way is to change the first two characters, then change the last two characters according to them, right? So the final string will be like this. The other way is to do like this, and then change the first two characters according to them, right? So this way both of the ways would take 4 operations. You can take either of the ways, both of them are equally correct, and both of the ways satisfy the conditions that are given in the question, right? Now interestingly enough, the length of S1 and S2, so S2 will always be smaller than equals to S. Their length is at least 1, and at maximum it is 1000. So we can definitely apply some n square algorithm, right? So how do we actually do this in n square? Now, as I already told you, the idea is very simple. If I have some string S1, let's say S1 is represented by some array or vector of characters. So let's say this is like this. And now we have our string S2, let's say it is of size 2, right? So what we can essentially do is we can start testing, and we will find the places where we can form S2. So for each index we can test it, right? We can test whether we can place S2 starting from here, whether we can place S2 starting from here, whether we can place S2 starting from here, right? So at each index we will try and test how many operations it will take. So this particular approach is going to be O of n square. Why? Because so in the first loop we will be going through this particular array index that we want to start our string S2 from here, or our S2 from here, or our S2 from here, right? And in the second loop we will be just matching the characters of the string S2 with string S1, right? So for example, let me just take the input test case only, A, B, B, A and B, B, right? So I had A, B, B, A. So it should not be B, it is A, B, A, 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 and the string S2 is BB, right? So this is our input test case. Now if I divide it into like this, these are the 4 characters that I have, and these are the 2 characters that I have in my string S2. So I'll try to like first set it in the first position, right? So if I want to set my string BB substring starting from the first position, what I'll have to do is, since A and B are not equal, I'll update the first index with B, right? Since I am updating the first index with B, I'll also have to update the last index with B, because the string needs to be a palindrome. So the total number of operations that I have taken till now is 2, right? Now the second string is already B, the second character is already B, so I don't need to change it. But the third character, which is like the opposite part of it, in order to make the whole string a palindrome, I also need to change it. So the total number of operations would be 2 plus 1, and that is equals to 3. Right. So this is the total number of operations required if I want to place my string bb starting from the 0th index. But in this case, you see that no matter from which index you start, from all of those indexes, you can find the substring bb, right? Now let us test from the second index. If we start testing from the second index, that is index 1, right? So first index is 0, then the second index is 1. So this was a, we don't need to take worry about this now. So the second index, it is already b, so no problems again. And the third index, it is all, so we have, since we have changed this into b, we have to change this into b as well. Now once I have set this particular character as b, I'll move on to the next character, but I find that it is already b because I changed it while I was making it b according to this particular character present at the first index. So this is already b, I don't need to change it, and this is a. So the total number of operations here would be 1. Why I changed this particular index to b? Because at index 1 my b was present and I wanted to make it a palindrome. That is why I had to change this particular index, right? So let us start from the second index now, or index 2. So this is index 2, right? Now I want the character at this particular position to be b, right? Because this is the first character of the string s2. So if I want to make it b, I can make it b. Initially it was a, so one operation would be required here, and I also want to make this b to make the whole string a palindrome, and it was already b. So the total number of operations in this particular case would be 1. Now the second character is a here, but I want to make it b according to this, so I make it b. And if I have made it b, I also wanted to make this particular character b, so I make it b. Both of them were a initially, so I'll have to make two more operations. The total number of operations is 3. Right. So this is how you can calculate that you have like, first of all, you can just match all of those strings with the characters of s2, and for each character, if you have to change that particular character, you just change it, and also make sure that the character on the opposite end of the string, that is, like for example, if you are at the ith index, then you have to make sure that the n minus I minus 1th index is also the same character. This condition is just to make sure that the string is a palindrome string, right? Now there is one more very important thing, that what you can do is, if you have changed a string, for example, if I have changed the first character of my string, while changing it, I must save this information that I have changed that particular character. So that, for example, I have changed this, I have not changed this yet, I have not changed this yet, and when I was changing this particular character, I also changed this particular character. I need to save this information. Why? Because this saving this information is very important. Otherwise, what will happen is, when you set the character at 0 index, you also set the character at the third index, right? When you come to the third index, you need to know that I have already changed this character in accordance to this particular character. So let me give you an example, you will understand it better. So if the string was ABAA, right, and the string S2, let's say it is ABAC, right? So you have set these characters, these are already equal, but you just made sure that these are also equal. So for example, let's say it was C initially, right? So now what happens is, you just check the first characters are equal, okay, well and good. The first characters are equal in both cases, but you also change this particular character from C to A just because you want to make this a palindrome, right? Now you check the second characters, great, they are also equal, but you change the second character, this particular character, to B also because you want the string S1 to be palindrome, right? Now when you check these two characters, they are different. Now you would want to change them, but you cannot change it just because this character has been changed to B because this was B, right? Now if you change it, it will like just become a loop in itself, because you change this particular character because this was B. Now if you change this to A, now again you will have to change this particular character to A. Let us discuss this particular scenario only. So if it was BA and the string S2 is also BA, right? Now if the first character is B, you would change the second character to B also, right? Because you want this to be a palindrome. Now the second character is A here, you change this to A, right? Now you erase this and change this to A. Now the first character should be equal to this particular character, so you also change this to A. Now again this is B, you have to change this to B, right? So this will like continue in a loop, and this will keep on going on. but you cannot perform this operation since you have to fulfill two conditions together. So you have to maintain this particular information also, that if you have already changed this particular position, you're not allowed to change it again, otherwise it will void one of the two rules, right? So this is the important thing that we need to take care of. So let us just quickly discuss the approach to solve this particular problem. Now we have been given two strings s1 and s2. For each index of s1, we will just test whether we can start placing s2 from here or not. So if we can place s2 from here, we will count the number of steps and just save it in our answer. So how do we test it? Whenever we just, for example, if I am at the 0th index of both the strings, I'll just check whether they are equal or not. If they are not equal, I just make them equal. And if I'm at the ith index of string s1, I'll just make sure that the n minus I minus 1 position is also the same character, just because I want to make the string a palindrome. Now I just mark both of these positions to that I have changed them, right? Why do I need this information? If I have changed them and there is a need to change them again, that means one of the two rules will always be voided if we start from that particular index. Like we have seen the example here. If you change one particular string, when we just try to change the other string, the previous rule was voided that this should be a palindrome, right? One of the two rules will always be voided whenever you try to change an already changed character, right? So this is why we need to store this information, that which of those places which we have already changed, right? So we just traverse through the string for every characters, and like for example, we have traversed the first character here, then we do for the second character here, right? And we just make sure that the string is a palindrome by changing the opposite end of the characters as well. So after we have done all of this, for all those characters we have not changed yet, we just make sure that they are equal to the opposite ends. That means the string is still a palindrome. So let me just show you the code now. The code is very simple. What I've done is I've initialized my answer with 2000, just because the length of the string is 1000. So the maximum number of operations you would need is 1000 itself. So I just taken a bigger number than 1000. So I've initialized n and m with the size of the string s1 and s2 respectively. Now I just initialize my for loop from I is equals to 0 till less than n minus m plus 1. So why this particular condition? Just because if I am at the n minus mth position, that is the last position, I can start my substring, second substring from. Otherwise I cannot fit into it. So for example, if I have the first string as a b b a and my substring is b, so this is the 0th index, this is first, second, third, and this is fourth, which is out of bounds, right? So n, the size of n is 4 and the size of m is 2. So second index is the last index from which I can start my substring. If I try to start from here, I will run out of bounds, right? So that is why I have taken less than n minus m plus 1, so that I can go up to n minus mth index. Now I will initialize my boolean vector change, which will store the information that I have changed that particular character or not. Now I create a copy of s1 in my string t. This is a temporary string, and I initialize my count with 0. So this will store the number of operations required if I start from the ith index. Now I just traverse through my second string s2, and I just check if t of I plus j. So I is the starting point and j is the index of the second string. If t of I plus j is not equals to s2 of j, that means that the current characters are not equal. So I just check if I have not changed them, I'll increment my count and set t of I plus j is equals to s2 of j. And the second thing what I do is, if I have already changed it, if I have already changed the current element, I just set count is equals to 2000 and I just break, because if I have already changed the current index, I cannot change it again, right? This is as simple as that. Now similarly for the part t of n minus I minus j minus 1, so that like it is very big, but it is essentially this particular thing, right? So if you are at index I, right, if you are at index I, its opposite end would be n minus I minus 1, but since we are at index I plus j, its opposite end would be n minus I plus j in a bracket minus 1, right? If you open the bracket, it would be n minus I minus j minus 1. So if this string is not equals to s2 of j and it is not changed yet, again this is a very important condition that we have to check that it is not changed yet, we just increment the count and change it, right? But if it has been already changed, all I do is I just like set count is equal to 2000 and just break out. Now I just said after I've changed both of them, I just set both of them as changed. Now after I have completed this particular loop, now where I have changed all the necessary characters, what I do is I just check for all the unchanged characters. So if I have not changed the particular character j, and I just check if it is not equal to its counterpart, then I increment my count, I make both of them equal and set the changed variable to 1 or true in both of these cases. So after I have executed this, I just said my answer is equal to minimum of answer comma count. So after again all the loop is completed, I just check if answer is equal to 2000. That means I have not found any suitable condition for my answer, and hence I return -1. Otherwise, I return answer variable. So this was it for today's problem of the day, special palindrome substrings. So as you can see, the idea was very simple, but the implementation is a bit lengthy, and I hope you guys were able to understand the solution. If you guys did, then you can drop a like on this video, and don't forget to subscribe to this channel. It really helps a lot, and it's always free of cost. So if you don't find the videos interesting later, you can always unsubscribe. And till the next video drops, keep coding, stay safe, bye bye.